Okay, thank you for inviting me and proposing me to do this presentation today. So I will try to introduce you to the AES Zoo system that we are implementing for the ANERIS project. I will try to be quite fast in order to allow some questions. And yes, I will check my time also. So the idea is to explain how we get data from the underwater vision profiler model 6 to your office on the web. What is the underwater vision profiler? This is the last baby of a long series of sensors that we developed at Laboratoire d'Oceanographie de Villefranche, which is connected with the EMBRC. That's why you introduced me as EMBRC. So the UVP6 is the second version of this system, which is commercialized today under a CNRS and Sorbonne University license to the Hydroptic company. So it's an on-the-shelf sensor that we deploy on many different platforms due to its easy integration. Basically, it drains very little power and it's small and it's not that expensive. As you can see there, we have it on CTD rosette, we have it on profiling vessels on cables, we have it on plankton nets, gliders, profiling floats, long-term moorings, landers, breath, and it can be also set on the bottom on coral reefs, like on this photo. Today, most of the UVP6 data are available on the EcoPart application. And this map, which is not that good, represents the total number of data from the sensor since it was introduced on the market in late 2019. There are today 170 units in operation, and on that map you can see that there are more than 22,000 profiles, because it can be utilized as a profiler or time series when it's on a fixed mooring or on a cabled observatory. And what is really interesting to see on this map, on this graph, showing the total number of data, basically images from different on the lab and in situ imaging sensors. You can see the fast increase in blue, the fast increase of the quantity of data provided by this sensor due to the fact that it's easy to integrate and easy to operate. What is this sensor? This sensor that we deploy during the ANERIS project. Basically, it's an in situ camera. It is utilized to count and size large particles. Basically, the lower limit, reliable limit for counting and sizing is 80 micrometer equivalent spheric diameter. So basically, the sensor is a particle counter for the large particulate matter, LPM, but it also records images, and it also permits to identify the plankton from these images, but also the aggregates, the detritus, which dominates the underwater assemblages largely. It can be 90% of aggregates versus plankton. And we do that for organisms above half a millimeter, I mean 6.6 millimeter in equivalent spheric diameter, for which we do have sufficient resolution to do a classification. And in that case, the sensor is a plankton and particle imager. What we do use the sensor for, basically it's for particle monitoring and the biochemical studies, mainly in the context of improving the knowledge on the carbon pump, which drains the anthropogenic and natural carbon dioxide from the atmosphere into the oceans. It's also widely utilized for plankton ecology, since we are now capable, thanks to the artificial intelligence, to classify easily the images. The UVP, this is a schematic of the UVP. Basically, it's conceived of a smart and intelligent camera containing a processing unit which is capable to record and analyze the images in real time, and a lighting system which creates a light beam of a well-known thickness. The light being placed at a known distance from the smart camera, from the optics of the camera, we can get reliable measurements on the objects that we record in the field of view of the instruments. So this is why we say it's particle counter. But to get the correct countings, we need to know the concentrations. And this conception allows each to know the volume of each image, basically half a liter per image, which is the intersection of the vision cone and the light beam. Because there is nothing in the background, the objects are visualizable on a dark background, which makes them very easy to process. We also use red light because it's not visible for the plankton, and as it does not penetrate in the ocean, the sunlight does not impact the measurements from the sensor. There is today one version, which is the UVP6. You can better see the image volume on that image. But we are also, in the context and in relation to the ANERIS project, we are also developing a new system which will see smaller targets. Today, we have one UVP developed in the context of the ANERIS project. We have one UVP deployed in the Smart Bay Observatory, EMSO Smart Bay Observatory. As you can see on this photo, the green water, it's a rich zone in the bay. And what you can see also on this photo is that we have two UVC light which prevent the biofouling on the sensor, because the sensor is now developed in the context of ANERIS for years underwater, and we need to prevent the biofouling on the optics of the system. There is another unit in OPSI in Villanova. In fact, it was the first to be deployed last spring, which also includes the two lights unit that you can, UV light unit that protects the camera. And you can see the camera and the lights are very clean in comparison with the other surfaces of the sensor. Today, the data from the sensors are manually extracted from the instrument, the UVP, which is connected to a junction box underwater. And there is a long cable, many kilometers cable to the shore, and where it's connected to a server and a power unit. Actually, we have to connect using a remote desktop application to download the data, process them, and import them in the EcoTaxa and EcoPart application that I will introduce. Next year, there will be an application which will automatize all this process. Today, the data from the ANERIS project, from Villanova and SmartAir, are imported in the EcoPart application, and they are public. You can download them, you can access to them. Today, in the application, there are more than 37 profiles, but only few are from the ANERIS project. And from the application, you can also visualize the ANERIS data. In red, you have the abundance of small particles for two size classes, very small and large ones, in Villanova, in nearby Barcelona. And in blue, you have for the same size classes the abundance, since we deployed the instruments last summer. We can also have it, you can zoom it for one day, as an example on this. And it's very curious to see that the abundance of small particles follow the same patterns for that day in both sides. The UVP is an imaging device, and you can see plankton images there from crustaceans, gelatinous bodies, filter feeders, fishes, and there are many fishes in these two observatories. We import these images in the EcoTaxa application, where they are automatically classified and where the expert can do a complementary manual sorting or validation. Again, these data are public. There are today 400 million images in this application, so not only from Villanova and Smart Bay. Some images can also be sorted in this Play for Plankton application, which is available on Google Play. and which permits to allow the public to classify plankton images and help scientists and also get knowledge of the plankton specimen that they can sort. Some results. Two categories of plankton is really preliminary because these data the acquisition is ongoing. But there is something we can see. On the top panel, you have the OPSI abundance of these filter feeders, the lavachians, during one day. And you can see that there is a variation with difference between night and day, while we don't see any variation in Spark Bay. For the fishes, we also see that there is more activity during the day than during the night. This is really preliminary. And basically what is important to consider for us for this ANERIS project is that we are acquiring a new type of data. Basically, the sensors were mainly deployed in open sea waters where we had much less influence of the fishes and where we had less influence from the shore. And that is the challenge we will face in the coming months of the project, which is to develop a new pipeline, a better pipeline to extract the information from the images, and also create a dashboard like this one to allow the public and any interested people to extract meaningful information from the sensors that are connected. And thank you for your attention, and I'm very happy to answer the questions you may have.
Thanks, Marc. Very interesting talk on the automatic information extraction system for zooplankton images. Do we have any question for Marc? Please raise your hand or write it in the chat. Or maybe Marc, there was this question that is quite interesting, and I think you can also answer since you're working on zooplankton. So the question was for Alex, who's working on, from Oslomet, who's working on, the multi-imaging underwater acquisition system, and he's using UV light as an anti-fouling system. And there was this question from Joanna saying that doesn't the UV in the camera impact the marine ecosystem? So I know that zooplankton and phytoplankton can be more impacted by the UV. Do you have an answer or a comment on that, Marc?
Basically, the UV light is utilized to prevent the biofouling to settle on the protected zones. I mean, the zones that are illuminated by the UV light. And the way it works is that it kills the DNA of the bacteria that first settle on the glass, on the optics, and allows allow the installation of the higher organism, more evaluated organism like the edges or some zoo organism. The UV light is very local, so it means that it's well concentrated and focused on these specific surfaces to be prevented. So that's the first point. And the second point is the UV light is not on all times. On the UVPs that are deployed at Smart Bay and OPSI, the UV lights are on half of the time. And because we want to be sure that they have no impact on the measurements, we created two data projects in EcoPart and EcoTaxa. One from using the data for which the light was on, and there's one for the data for which the light is off. And basically, at the moment, we see no difference, but we keep the possibility to evaluate a possible impact of having the UV light activated on the plankton and on our observations.